Hello, my friends. Welcome to Concept 4.2 Real versus Nominal Interest Rates. Let's dive right in. These are familiar terms for you, so that's good news. We're going to add a couple of layers to this and talk about where those interest rates are created in the loanable funds market and figure it out from there. Okay, so first, in real interest rates, those are actually created in a market, and we call it the loanable funds market. So there's demanders and suppliers in an equilibrium, and if you think about it, it makes sense. What are real interest rates? They're the price of a loan, the price the borrower pays in order to borrow, right? And of course, it's going to be demand and supply that creates that price of that loan or that real interest rate. Because in a product market, it's the demand and supply that creates the price and quantity of that good that's being bought and sold. So there's some logic behind this. But the loanable fund market actually looks a little bit different. The demanders are actually borrowers. The people who demand loans are people like you and me, households, businesses who are taking out loans to build new factories or buy capital goods, and the government who's taking out more funds in order to buy public goods or public services or fund their campaign. The other side of it are suppliers, and the suppliers, most people think banks, right? And sure, banks supply, but they're actually just the facilitators of those loans. The real suppliers of the loanable funds are people like you and me. Banks don't start with money. We take our money and say, hey, keep this safe for us for the future so that we can have access to it. When we give the bank our money as savings, they take that money and they lend it out, right? So it's households that are saving, it's businesses that are saving, it's the federal government that saves, not very often, but they could save. It's those same three entities that are putting their savings aside. So when there's an increase in saving or an increase in borrowing, that's going to manipulate those curves and create different real interest rates. Okay, makes sense? So what are real interest rates? Real interest rates are defined as the percent increase in purchasing power the borrower pays, right? So I'm giving you my money, I'm lending it to you. That money has purchasing power today that I'm not going to get to take advantage of. So I want you to cover that. I want you to cover that. If I bought equipment today, it would appreciate in value over the next year. Or if instead of giving it to you, I could have put it in a bank account and gotten that interest back. So you are going to pay me the interest, which offsets the purchasing power increase that would have happened over time. That's the idea. You don't really need to know that. You just need to know real interest rate is the price of a loanable funds, and you should be in good shape. Now, remember, real interest rate is adjusted for inflation. It's nominal interest rates minus anticipated or expected inflation will give you real interest rates. Remember, you don't pay the real interest rate. That's just profit for businesses. You pay the nominal. So let's break that down a little bit more. Nominal interest rates are not adjusted for inflation. This is the percent increase in money that the borrower pays. Right? They actually pay this amount and it's not adjusted for inflation, right? So you think of it this way. Nominal interest rates are real interest rates plus expected or anticipated inflation. Banks charge this higher rate because they don't want to be holding the bag for inflation. Like, we know inflation is going to happen. We know that banks or lenders are one of the people that are being hurt by this, right? If I lend this money out, I'm going to get paid back money that's worth less if I don't adjust for inflation. So they add inflation to it. Real interest rate is their profit, add inflation to it, and charge you the nominal interest rate. So nominal is always, always, always what the borrower pays. Real is the profit the bank gets to take home after adjusting for the inflation losses. So I get rid of the inflation losses and I get to keep the real interest rate as profit. So that really matters for the banks. Now, sometimes banks get this wrong. They don't anticipate inflation correctly. And if they underestimate inflation, if there's unexpected or unanticipated inflation, then their real interest rates, the amount that they get to take home, falls as a result. And so lenders are one of the ones that are hurt by this unanticipated inflation. Okay, so you see how that's connecting a little bit. So nominal and real interest rates, here you go. Nominal, there's 9%. The real interest rate was 4%. The inflation premium was 5%. The borrower will pay 9%. That's the difference between real and nominal. Nominal is real plus inflation. Nominal is what you actually pay. Real is what the bank takes home as profit. Let's try out a little practice here. Okay, so you could copy this down or just follow along with me. So row number one here, if our nominal interest rate is 10%, and our inflation rate is 8%, then what's our real interest rate got to be? Well, we know that nominal minus inflation equals real. And so, uh, apparently I didn't animate that correctly. That's okay. We'll do it together. It's going to be 2%, right? Nominal minus my inflation rate equals 2%. Perfect. I jump down to the next one. What's my nominal interest rate if my inflation rate is 12% and my real interest rate is -4? It's going to be 8%. Catch that? So if my nominal is 8 and I adjust for inflation, banks are actually going to lose money in this situation, -4% as a result. That's what we're talking about when we say that banks underestimate inflation and it robs them of their profits. If my real interest rate is 7, what's my inflation rate going to be when my nominal interest rate is 12? It's going to be 5% because 12 minus 5 equals 7. If my nominal interest rate is 7, my inflation rate is 10, it's going to be -3. You should start to see a pattern here because it's nominal minus inflation equals real. 5 minus what is going to equal 7%? What? Well, it's got to be negative, right? That means we didn't have inflation, we had deflation. So as a result, I charge you 5%, but I actually make greater profits because you're paying me money that's worth more than it was when I lent it out to you. And then final one, if this is 6%, then my nominal interest rate must be 4 to kick out a -2 number. And that is really what you need to know. Let's clear that out. I think I got all those right. I did. Perfect. All right, let's keep going. Okay, so we use real interest rates for a couple of things. They teach us about bonds, which we talked about a little bit earlier, but they also help us understand the time value of money. Money and time have a relationship, right? So money that I have now will accrue value in the future. And money that I don't have now but have in the future is worth less if I had it today. Okay, so we actually know this pretty well. If I have $100 and I say, okay, there's a 10% interest rate on it, what's that $100 going to be worth a year from now? $110. That's the time value of money. Time actually makes money more valuable because money, when I lend it out, has an interest rate tied to it. It has value. People will pay you for that purchasing power. Okay, so you can actually calculate the future value of any dollar amount. All you need to know is the interest rate, the number of years, and the amount of money. And your equation looks like this. And it seems pretty intimidating, right? It's the number of dollars times 1 plus the interest rate to the power that is the number of years. Now, here's the good news. You have to be able to do this without a calculator. So the number of years is always, always, always going to be 1. Okay, so this will always, always, always be 1, which means that you can pretty much ignore the what do you call that, exponent? I don't know what you call that. You can ignore that. It doesn't really matter because it's always going to be 1. They'll say, hey, what's the value of $100 1 year from now? You plug 1 in those sections. Interest rate is always going to be in hundreds form or decimal form. Okay, so that's just a memorization thing. I'm going to add that in decimal form. So really, it's just the amount of dollars times 1 plus that interest rate in hundreds. That will get you your future value. Let's try one out. So let's say we have an interest rate of 10%. So if I save it, I get 10% on it. And we're searching for the future value of that $100 a year from now. So if I put it in that bank and I get the 10% interest back, what's it going to be worth 1 year from now? Now, most of you can just do that in your head, but the equation looks like this. I take that dollar amount, 100. I take the year amount, 1 year. I plug that in here, and I plug that in here, but I ignored it because it doesn't really matter. And then I take my percentage, I convert it into decimal. So it's not 10%, it's 0.1. So it's going to be 1 plus 0.1, or 100 times 1.1. And that's going to kick out a future value of $110. Now, if instead of 10%, this was 20%, then it'd be 100 times 0.2, 1.2, sorry. If it was 50%, it'd be 100 times 1.5. And really, it's that simple. You just do 1 point, whatever the percentage is, and that will get you the right number. That's the future value. It tells you if you take the money, instead of spending it today, you just put it in an account that pays that interest, you're going to make this amount of money in the future. You can use exponents for future value if you want to go 2 or 3 or 10 years from now, but just leave this money alone. How much value is it going to get in the future? But you don't have to do that for AP macroeconomics, but you might want to do it for your future. It's up to you. All right. You can also calculate the present value of something, right? So I could say, hey, in the future, you could either have $100 today or $110 in the future. Which should you choose? Right? That's often how these questions are framed. Should I take $100 today or 110 in the future? I don't know. I need more information, right? So you can figure that out. The present value of $110 in the future, I can figure out the present value if I have uh, those same variables, right? So if I have the amount of dollars, X, I have the number of years, which is still always going to be 1. It's going to be 1 plus the interest rate in hundreds. So this is going to be a decimal here. And this is always going to be 1. So really, it's just the number of dollars divided by 1 point, whatever your interest rate is, right? So if my interest rate is 10% and the amount of money is $100 and the amount of years is 1 year, then it'll just be 100 divided by 1.1. So this is just like the other equation, but instead of multiplying it, I divide it. Or in that situation, I said, hey, $110 in the future, I take that $110, I divide it by 1.1, and that will tell me how much it is worth today, which should kick out 100 bucks. So the answer is, I don't know. I would take either. Okay, so that's how you do it. You just divide it by that. Let's do a quick example of it. So again, we have 10% here. And we're searching for the present value of $100 received next year. So they say, hey, you get $100 a year from now. What would that be worth in today's dollars, right? And so I would take that $100, plug it in, and then be 1 plus 10% in decimal, which would be 0.1. So 1.1 to the first power, which is just 1. So 100 divided by 1.1 will be $90.91 if I plug that in. So getting $100 a year from now is the exact same of getting $90.91 today and putting it in that savings account. So would you rather have $100 a year from now or $50 today? And the answer is I'd rather have $100 a year from now, all other things constant, because it's going to be worth more than $50 today. It's going to be worth $90.91. That's the idea. Now, if the logic of that breaks down on you, just know the equation. If I'm looking at future value, it's number of dollars times 1 point, whatever the interest rate is. If I'm looking at current value, then it's whatever the dollar amount is divided by 1 plus whatever the interest rate is in hundreds. That's it. So if the interest rate is 10% and the dollar amount is 100, future value, $100 times 1.5. Present value, $100 divided by 1.5. If I was 50%, I don't remember what I said. I think I said 50%. All right, cool. Let's keep going. Hey, actually, let's not. That's it for that concept. Future value, interest rates, nominal versus real interest rates. Hopefully that made a little bit of sense to you. We'll go over it again in class when we come back together. Until then, I'll see you. Make sure you do that Khan Academy. Peace.